question we have here says that a piano has been pushed to the top of the ramp at the back of a moving van. The workers think it is safe, but as they walk away, it begins to roll down. Uh-oh! It rolls down the ramp. Neglect friction between piano and the ramp. So the question is, if the back of the truck is 1.4 meters above the ground and the ramp is inclined at 30 degrees, how much time do the workers have to get to the piano before it reaches the bottom of the ramp? I hope they can save the piano. Well, we're going to have some fun in this question. Now let's get to the solution and explanation.
Like the leg of the triangle?
Uh, Good. So your question is that's a very good question, because that's the first thing you need to know there. If the ramp is like this, 1.4 meters is this.
Oh, okay.
Because it says that if the truck is 1.4 meters above the ground and the ramp is inclined at 30 degrees, the angle is 30 degrees. So piano is falling off. The question is, how much time do the workers have to get to the piano before it reaches the bottom of the ramp? Well, this is kinematics. It's not stated, but we know it has to be. Based on what we're told, what are the quantities that we can extract from this situation? Like, what do we know here?
We know that the initial velocity is 0.
Good. That's the first thing. And what else do we know?
The acceleration is gravity times sine 30.
Good job. So, which is going to make negative 9.8. Yeah, let's just put gravity sine 30. Because this is always true whenever something is at an incline. Whenever something is at an incline, gravity has to be scaled down by the sine of the angle the incline makes. So the next thing is that, okay, we need 4 things to use kinematics. Now, it could either be this or this. Because obviously this first equation involves final velocity, and we don't want to mess with final velocity in this question, because the question is not how fast is it going here. The question is how much time. So we're going to be using this or this. Well, this involves final velocity, so we also don't want to use this. We want to use this one. The only thing else, the fourth thing we have to bring in now is the delta x.
That would be 1.4, right? No.
But here's the trick. Delta x is actually this. It's going to be related to 1.4 using trigonometric ratios.
Yeah.
So the way to do that is to say, so we have to do a little bit of work to find delta x. We would have to say that the sine of the angle soc à toi is what? 1.4 divided by what?
By x.
By delta x. So if we move things around, we'll get that delta x is 1.4 over the sine theta. And theta here is 30 degrees. So that should be about 2.8. Do you agree with that?
Let me see if I can get that. How do I type that into the calculator? Like, how do I
This
work
right
on
here,
that?
this, you would say
Yeah.
1.4 divided by parentheses sine 30 degrees. Or what was your question precisely?
Why is it? Okay, never mind. I got it.
Yeah.
2.8.
2.8. 2.8 meters. But that's, yeah. So let's just go back to this equation real quick. Like, if we didn't want to do a lot of work, we know that delta x is initial times time plus half at squared. The initial velocity here is 0, so we know that delta x, because this is going to go to 0, is half times at squared, right? Because the initial velocity is 0, so the first term, the v initial times time, is just going to go away to 0, right? Do you agree with that? Does that make sense?
Can you repeat that again?
So if we're using this equation right here, delta x v initial times time plus half at squared, because the initial velocity is 0,
Yes.
that means this is going to go to 0 because 0 times time is just going to go to 0. So you're left with the second part of the right hand side, half at squared. So as a general rule, it's better to solve for time before you plug in the numbers. And the way to solve for time is to multiply both sides by 2, so that gets rid of the half. Divide by acceleration and take the square root, so that you'd have that time 2 delta x divided by acceleration square rooted is the time. So that 2 times 2.8 divided by
Negative 4.9.
yeah, that's that. I believe that's so. What do we get?
You can't take a square root of a negative, right?
So yes, that means we should have taken this to be positive. That means we need the magnitude of the a.
Okay, so I just take
The magnitude.
Okay, so I got 1.06.
Good. 1.069. And then to two significant figures.
Um, 1.0.
6 is
1.1?
1.1. Good. Why is it 1.1 and not 1.0?
Because I rounded this 6.
Up. Good. So 1.1 meters per second. Actually, we're talking about time here, so it's in seconds, not acceleration. So 1.1 seconds. That's like those the workers have to be on top of their game. They only have a second. Oh, this piano is off. All right, we're going to try and move real quick through the next one.
Okay. 3.20.
Yes, 3.20. If the driver lets the car coast, okay, a car turns into a driveway. Through this explanation, you have gained a better understanding of how to apply vectors and components in solving a type of kinematic problem. And I'm going to give you information on how you can contact me if you want tutoring. I've had more than 10 years of working with students at all kinds of physics, including high school, AP physics, and college physics. Physics is my best subject. I'm always glad when the light comes on in the mind of students as they get to understand physics. So here are the very affordable rates that I offer, and a trial will convince you. I'm looking forward to helping you attain success.